I'm Anil Kumar and I'm sharing with you some excellent questions which I came across in test papers. And now let's look into some ways to solve it and to really understand the topic with the help of this question itself. So the question is to understand Cartesian or scalar equation of a line. It says describe the line 3x minus 2y minus 12 equals to 0. Graph the line and explain how the normal might be used to calculate the shortest possible distance from some other point on the plane to this line. Okay, let's first see how to draw this line and then we will describe it also. So let me draw 2D or Cartesian plane here. So we have an equation given to us as 3x minus 2y minus 12 equals to 0. Now, this equation is in Cartesian form and it helps to find x and y intercepts very easily. And with that, we can actually draw the line. So what is the y-intercept and what is the x-intercept? To find y-intercept, we can place x as 0. So if I put x as 0, then I get y-intercept. So my equation will be 3 times 0 minus 2y minus 12 equals to 0. And that gives us y equals to, since this is 0, 12 divided by minus 2, which is minus 6. So we can plot this line. We can plot this point first. And we get this point minus 6. Let me make a small scale here. 1, 2, 3, 4, 5, 6. So that is minus 6. So we get y-intercept right there. Now to find x-intercept, let's substitute 0 for y and get x-intercept, right? So we get x-intercept as y is 0. So we get 12 divided by 3, which is 4. So we get 4 comma 0, right? So let's plot this point. This point will be 1, 2, 3, 4. So that is my x-intercept. Now if I join these two, I get the line in R2, right? So here is the line 3x minus 2y minus 12. So this is x-axis, that is y-axis. This point is 4 for us, the x-intercept. So as you can see from here, the line has a direction vector, which is, if you see from here, going from here to here is like what? 4 x direction and 6y, right? So that gives you the direction from here, 4, 6, which can be simplified, right? So we can go, if we have to go from here to this place, then we go 4 units right and 6 units up. Correct? So that is how we get our direction. So we can write this direction as 4, 6. Now in a simpler form, we can also write this as 2, 3. So 2, 3 becomes our direction for this particular vector. The equation 3x minus 2y minus 12 equals to 0 is the Cartesian form of the equation of a line. And from this equation, we actually get the normal straight away. So normal can be read from this equation, and the normal to the line is actually equals to 3, minus 2. We just said that the direction to this line is, let's say m, equals to 2, 3. Now if this really is the normal, then their dot product should be 0. So let's test it out. So the dot product will be 2, 3 dot 3, minus 2. So we get 2 times 3 is 6 and 3 times minus 2 is minus 6. That is indeed 0. So what we learn from here is that the line described to us 3x minus 2y minus 12 equals to 0 is a line which gives us the normal vector, and the normal vector for this line is 3 comma minus 2 as mentioned here. Now I can draw this normal vector in the Cartesian plane, which is 3 comma minus 2. That means 1, 2, 3 units along x and 1, 2. So somewhere here, right? So we get this normal kind of in this direction. So that is my normal to the line. Now let's move on to the next part so that we can connect what we are talking about with what is required to be answered in part 2 of this question. So we understand that the line 3x minus 2y minus 12 equals to 0 is in the Cartesian form, where 3 and minus 2 is the normal to the line. Now, part B of this question is, graph the line and explain how normal might be used to calculate shortest possible distance from some other point on the plane to this line. Now, as you can see, if I take any other point on this plane, let us take one. This is 4, let's go ahead, 5, 6, and say 1 and 2. Let's say this is our point 6, 2 on the line. Well, it became very close, doesn't matter. Let's say this is a point which we take on this line, which is 6, 2. Now, we have to find what is the shortest distance between this point 6, 2 from the line. So what we can do is, we can draw a normal from the line. This normal will be parallel to the normal given to us, right? And the shortest distance is actually along the normal. Do you see that? So if I connect this, any point on the line for that matter, I'm taking this x-intercept for the time being. If I connect this with my exterior point, let me call this as Q, and let me call this point as P, the x-intercept. Then as you can see, the shortest distance between Q and the line, let's say line is L1, is actually the projection of PQ on the normal. Do you see that? So Qn, the projection of PQ along the normal, is the shortest distance. I should say the scalar projection. So the magnitude of the projection from Q to any point on the line, we could have taken a point this also, right? The projection will give us the distance of the point from the line, and that distance is going to be the shortest distance since it is along the normal to the line. Do you understand? So we can find shortest possible distance from some other point on the plane to this line by finding the projection of the vector joining point on a line with this point to the normal. Do you understand? So I can write this as Qn, magnitude of Qn, which actually is projection of, in this case, PQ on normal vector. So that is the magnitude of this gives us the shortest distance, right? I hope you can visualize it and understand how we can calculate its magnitude just now. We will do it and check our answer. So the point is Q62 and we have taken 0, 4 as P. So the projection is actually PQ, magnitude of PQ, dot the direction vector, the normal direction vector, which is 3 minus 2. Let me write like this now, 3 minus 2. I should have written like that, PQ. We'll find it now, okay? 3 comma minus 2 over the magnitude of direction vector, which is 3 square plus minus 2 square. That gives us the shortest distance. And what is PQ? PQ is Q minus P, right? The points, respective points. We'll get those points now. 6 minus 4 is 2, and 2 minus 0, because the point is 4 comma 0, right? 2 minus 0 is 2. And we have here dot of 3 comma minus 2, right? Divided by 3 square, which is 9, plus minus 2 square, which is 4. Do you see that? And now from here, we can get our answer. 2 times 3 is 6, plus 2 times minus 2 is minus 4 over square root of 13. And that gives us answer, which is 2 over square root of 13. Remember, we have to take absolute value of this, right? We're talking about absolute value of this, right? So in any case, this was positive in this case, but in case it is negative, you have to take absolute values. Let me make sure that we do, because dot product can give you negative results, right? So that becomes the shortest distance from a point which is selected Q anywhere outside the line but on the plane, and that is how we get it. So I hope you understand the significance of normal with respect to the line given to us and this form of equation. So this form of equation is used widely to find the shortest distance from a point which is not on the line. Well, if you do it, if the point is on the line, you'll get 0. So the shortest distance will be 0 also, right? That is also the correct answer. And that's how we can apply this and find the shortest distance from any point. So in short, the shortest distance is always along the normal, and it is the projection of the vector joining the point and any point on the line along the normal. I hope the point is absolutely clear. Go through it once again and understand this very important concept. Thank you and all the best.